So let me just start with this question. What if you could learn the language that literally writes the rules for everything? I'm talking about the hidden code behind financial markets, behind secure communications, even behind the fabric of space and time itself. That's what a math degree is really all about. And this right here is the heart of it. Getting a BSc in math isn't about memorizing formulas. No way. It's about becoming fluent in a master language, a universal language that lets you describe, analyze, and ultimately solve problems in pretty much any field you can possibly imagine. Okay, so just like any language, you've got to start with a grammar, right? The fundamental rules, the structure. In the world of mathematics, we call this pure mathematics. This is the why behind everything else we're going to talk about. You know, pure math is where we get to explore the foundational logic of the universe. Seriously, we're not trying to solve a specific real-world problem just yet. Instead, we're uncovering these deep, elegant principles that make all the practical stuff possible. Think of it like finding the secret blueprint for reality itself. So let's look at the toolkit you get. Algebra, that's the study of structure and rules. Calculus, that's the language of change and motion. It describes everything from a planet's orbit to how the stock market is doing today. Then you have analysis, which is what gives us absolute certainty. It rigorously proves why our numbers behave the way they do. And topology is just fascinating. It's the study of shape and space, where a coffee mug and a donut are, mathematically speaking, the exact same thing. These are the core rules of our new language. Okay, so once you've got the grammar down, it's time to start writing, to actually use this language to describe the world around you. And this is where applied and discrete mathematics jump into the picture. So this is a really important distinction to make. If pure math is the why, the deep fundamental theory, then applied math is the how. It's the set of tools you grab to go out and tackle real-world challenges. It's the bridge that takes you from abstract ideas to concrete, tangible solutions. And this is where it gets incredibly powerful. You're modeling things like population growth using differential equations, you're predicting randomness and managing risk with probability and statistics, you're building powerful computer algorithms with numerical methods, which are basically just clever ways to get really good answers to ridiculously complex problems. And with discrete math, you're solving the very puzzles that make computer science and all of modern cryptography work. You are literally writing the code of the modern world. So learning the grammar and vocabulary, that's one thing. But what does it actually mean to be fluent in this language? Well, it means you've picked up a set of insanely valuable skills that go way, way beyond the classroom. A math degree basically gives you 4 core superpowers that you can take with you into any career you choose. Let's break them down. First up, analytical thinking. This is the art of looking at some massive, intimidating problem and seeing it not as one giant monster, but as a bunch of smaller, totally solvable pieces. Trust me, that skill is an absolute game changer in any job. Second, you become an expert problem solver. And I'm not talking about just knowing the answer ahead of time. I mean, you can look at a complex maze with no clear path and have the confidence and the logical tools to build a solution from scratch, often in a really creative way. Third, you walk away with serious computational skills. You learn how to speak the language of computers, using powerful software like Python, MATLAB, and Mathematica to run simulations, crunch data, and bring all those mathematical models to life. And finally, maybe the most underrated skill of them all, communication. I mean, what good is a brilliant solution if you can't explain it to your team or your client, right? You learn how to take these incredibly complex ideas and translate them into clear, compelling language that other people can actually understand. So, you've learned the language, you've mastered the skills, you're fluent. Now what? What conversations can you join? What tables can you sit at? The answer is pretty much any of them. Your fluency is in crazy high demand across just about every modern industry. In finance, you're not just an analyst, you're the person building the models that price risk and drive the entire market. In tech, you're the data scientist finding patterns in chaos. In security, you are literally the code maker and the code breaker, protecting all of our digital lives. Your skills are the absolute foundation of these fields. So let's just tie this all together. The whole journey is really a simple 3-step process. First, you learn the language by getting the degree. Second, you choose the conversation you want to be a part of. You pick a sector that gets you excited. And third, you get to work, solving fascinating, important problems by applying your unique toolkit.
And that's really the point, isn't it? A degree in mathematics doesn't just hand you a piece of paper, it gives you a powerful new lens to see the world and an incredible toolkit to change it. The world is absolutely full of problems, so the only question left is, which one are you going to solve?